start our next trig topic just looking at radian measure, so another way of measuring angles, a circular measure, and the basic conversion. Well, I think of it this way because I can relate that a lot easier, because 360 degrees, so one complete circle, and I can think of that as 2 pi because we know circumference of a circle, 2 pi r. Common conversions, let's just flick through them. We'll see these a lot because they're our exact values basically. So 30 degrees, pi on 6, 45, pi on 4, 60, pi on 3. Okay, 90 is of course pi on 2. So they're our acute angle. Well, pi on 2 is not acute, but our first quadrant angles. Now, we move to our second quadrants, the ones we'll see appear a lot. 120, 2 pi on 3, 135, 3 pi on 4, 5 pi on 6 for 150, and then we go around to pi. That brings us to our third quadrant. 210 is 7 pi on 6. Then 5 pi on 4 for 225. 240 is 4 pi on 3. 270 is 3 pi on 2. And we get to our last quadrant, 300, 5 pi on 3, 315, 7 pi on 4, 330, 11 pi on 6, 360, 2 pi. So these are the ones we see a lot, but of course we're not restricted to that. Anything can be converted. So 67 degrees is 67 pi on 180, so multiplied by pi on 180. A decimal approximation is only 1.1693. So a radian, when you think about it, is actually quite large. 36 degrees, 36 pi on 180. That one I can write nice and neat, pi on 5. Going back the other way, of course, so pi on 8 radians. Multiply it now by 180 over pi. The pi's cancel. 22.5 degrees. Not everything's going to have a nice pi to cancel, so 111.1. Well, I just go to a decimal approximation for that one. Woo, look at that, 6,365.6 degrees. 11G is just basically working with the conversion.